Now, let's learn automotive assembly and adjustment technology. Project 3, Lesson 1, Engine Structure and Process Flow in Powertrain Assembly and Adjustment. The engine is the heart of the automobile. The engine assembly line is a critical stage in automotive final assembly. Task 1 is to sort out the components of the engine's 2 mechanisms and 5 systems. Identify the main assembly line and the auxiliary assembly lines. Study and analyze a typical engine assembly accident case. First, the basic structure of an engine includes 2 major mechanisms and 5 major systems. Crank connecting rod mechanism. The main components include the cylinder head, cylinder block, pistons, connecting rods, crankshaft, and flywheel. The valve train mechanism. The main components include timing gears, timing belt, camshaft, intake valves, exhaust valves. The fuel supply system. The main components include the air filter element, intake and exhaust pipes, fuel tank, fuel injectors. The lubrication system. The main components include the oil pan, oil pump, and oil filter. The cooling system. The main components include the radiator, cooling fan, and coolant hoses. Second, engine assembly consists of parts assembly and engine module assembly. The figure shows a typical engine assembly line. It consists of 1 main assembly line and 3 auxiliary assembly lines. The main assembly line process starts with the transfer of the cylinder block onto the line. This is followed by installing the crankshaft, pistons, and connecting rods, mating the cylinder block and cylinder head, and installing the timing mechanism. Then install the accessories. This continues until the engine undergoes factory testing and a test run. The auxiliary assembly lines include the crankshaft sub-assembly line, piston and connecting rod sub-assembly line, and cylinder head sub-assembly line. There are so many engine parts. Is it possible to install something incorrectly? What would happen if an error occurs? Next, we will share a case of an engine assembly accident. The 2019 Xi'an Consumer Rights Dispute Case. Why did a brand new sedan develop an engine oil leak? Because the consumer complaint process did not progress smoothly. The final appraisal by an authorized institution concluded that, first, the right side of the engine cylinder block was damaged and leaking oil. During engine assembly, a fixing bolt of the oil splash guard was left behind inside the engine. During high-speed engine operation, the big end of the number 2 cylinder connecting rod struck the misplaced bolt. This caused the bolt to puncture the cylinder block. Second, the automobile engine had no history of replacement or repair. Third, the engine had assembly quality defects. This constitutes a product quality issue. Please note this point. The accident was determined to be caused by assembly quality defects during the assembly process. Can we trace it back to the operator responsible? Please refer to the lubrication system assembly diagram in the service manual. Which component was involved in this accident? Please find it. In the diagram, number 11 is the oil splash baffle. Number 15 is the mounting bolt. This is the mounting bolt for the oil splash baffle. An assembly error occurred. This caused direct economic losses of several million yuan. The indirect economic losses exceeded 10 million yuan. This is a hard lesson. Based on this case, we must learn the correct principles for incident handling, namely, the 4 musts principle. The case must not be closed until the cause is identified. The case must not be closed until those responsible are held accountable. Do not let it pass until corrective actions are implemented. Do not let it pass until relevant personnel are trained. The 4 musts principle must not stay at the slogan level. The cause must be thoroughly investigated. Responsible personnel must be held accountable. Corrective measures must be implemented. Lessons must be learned. More importantly, actions must be taken. Apply the lessons learned to prevent similar incidents. Task 2 of this lesson is to study the powertrain assembly process. Identify and analyze key workstations. Powertrain and accessory sub-assembly. This refers to mating the engine with the transmission, the subframe, and other major components. On the chassis marriage fixture, following standard process flows and methods. For a certain automobile model, the powertrain and accessory sub-assembly consists of 9 workstations. The workstations for mating the transmission, alternator, compressor, and accessories include MA01, MA05. The workstations for assembling the starter motor, condenser, and accessories include MA06, MA07. The workstations for mating the engine assembly with the subframe and assembling accessories include MA08, MA09. Please go to the online course materials. Download and study Table 3:1, Process Flow for Powertrain and Accessory Sub-Assembly, Model X. Then analyze the operating steps, methods, diagrams, safety precautions, part names, and torque values for each workstation. For example, at MA02, install the alternator. Before installation, check that the alternator model is correct. For example, at MA03, install the compressor. Check the part surface for damage. Pay special attention to the connector terminals. Also check that the bushing is in place before installation. Please study and analyze the other workstations independently. Now, please work in groups for discussion. Complete the in-class assignment. Then complete the online assignment and extension tasks. Thank you for watching.